Yes. Can't wait anymore. I have a catcher. Okay? Baseball. Catcher takes a ball, throws it 37.5 meters per second. That's a good arm, by the way. It's a good 20-mile-an-hour fastball. From a catcher. Throws it horizontally towards second base. He releases it approximately 2 meters above the ground. Oh, we'll call it 2.0 meters above the ground. So exactly. So he's this kind of motion. Throws it straight horizontally. Wants to throw it on a rope to get it to second base. Throwing out a guy, stealing. How far does the ball fly before it hits the ground? It's going to hit the ground. Doesn't make it to second base. If you throw it on a straight line from home plate to second base, you will not make it. Why are pitchers' mounds elevated? So they can throw more on a straight line. They're throwing downhill all the time. All right, in order to solve this problem, any type of problem like this, we start out the same way. We want to know distance, acceleration, time, initial velocity, final velocity. Exactly like we have been doing. Except now we have to worry about two dimensions. They are independent of each other, so we're going to say, all right, we're going to talk about what's happening horizontally and what's happening vertically. Distance, acceleration, time, initial, and final. Now we have to go through and figure out what do we know and what do we need to know. What doubt? What do we actually know? 37.5 meters per second. What is that? The initial velocity in which direction? Horizontally, because he's throwing it horizontally. Now, does that speed change? No, because there's no air resistance. The horizontal speed doesn't change. What happens to the ball? It starts to fall. Its vertical speed changes, but its horizontal speed does not change. Its horizontal speed, acceleration is 0. Its final is 37.5 meters per second. Now, is the ball actually traveling faster than that when it hits the ground? Yes, because it's going to have some vertical component to it. What else do we know? No, for anything. Okay, we know the vertical distance is 2.0 meters. What else do we know? We know the vertical acceleration is 9.8 meters per second squared. We know one more thing. Nope, that's what we want to find. What? The initial vertical velocity is 0. As soon as I let go of it, has it started to fall yet? No. But as soon as I let go, then it will start to fall. So its initial vertical velocity is 0. We talk about just before it hits the ground. Otherwise, yeah, everything's final velocity is 0. Because it's going to be laying there. Yeah. But the time becomes infinite, so. Now, so this is what we know from our problem. What do we want to find? Horizontal distance. Now, in order to find horizontal distance, what do I need to know? I need to know the time. I need to know how long it's in the air. Well, what determines how long it's in the air? How high you launch it from. Vertical determines time in the air. What do we know about the horizontal and the vertical time? They're the same. It can only be going forward as long as it's falling. As soon as it stops falling, in other words, hits the ground, it's not a projectile anymore. So vertical determines time. So let's look at our vertical. See, do we have enough information here that I can figure out vertical time? Yes. What equation would relate these top four things? That one right there. V0t times the time plus 1/2 at squared. Works out great because initial velocity is 0. That goes away. So time would be the square root 2d over a. I just went and solved that equation for time. I did algebra. I had d equals 1/2 at squared. I multiply up to 2, divide by the a, take the square root. These two equations are exactly the same thing. If you can't do the algebra, you need to know two equations. If you can do the algebra, you only need to know one. So time would be 2 times my distance of 2 over 9.8. Take the square root. 0.64. Now, think about that. Does that make sense? Is that a reasonable amount of time? If I take a ball and I release it from 2 meters up here, is it going to be a little over half a second before it hits the ground? Yeah. If you came up with 6 seconds, would that make sense? No. It's still falling 2 meters. You're only falling 2 meters. After a big hole in the ground. So we know our time. That seems to make sense. Our time is 0.64 seconds. So our distance, we know that speed is distance over time. So speed times time is distance. 4 times 37.5 would be your distance the ball would travel. Nope. Be changing via. All right. So how far does it travel? 24 meters. 24 meters is approximately 72 feet. How far is it from home plate to second base? Well, how far is it from home plate to a pitcher's mound? 66 feet, somewhere around there. So the ball would land, this ball, figuring it's 60 feet up pitcher's mound, would land, what, 12 feet behind the pitcher's mound? So even no matter how hard you throw it, it isn't going to make it there. Like I said, that 37.5 meters per second, that's a big fast. Do you see how you do it though? You have to think vertical and horizontal components. You have to treat them separately. Now, let's say that I want to throw it all the way to second base. I can't throw it any harder. What do I need to do? I need to throw it at an angle, right? If I take my gun, got anything left in here? Instead of shooting directly, if I shoot at an angle, now I can shoot a lot further. Although if I shoot it straight. That wasn't the eye, it was the forehead. The odds hitting that, these things don't travel real